Dave May is Senior Cyber Intelligence Advisor at the U.S. Army Cyber Center of Excellence and Army Training and Doctrine Command. And CW5 Travis Ysen is Senior Technology Advisor G39 at Army Cyber Command. Welcome, gentlemen. Thanks for joining me today. Dave, I start with you. What are we learning in Ukraine that is applicable to the work that the United States is doing and that you and your team are doing in particular about electromagnetics?
Great question. So we're learning quite a bit, actually. We've recognized that electromagnetic warfare is becoming a predominant factor on today's battlefield. It is successfully degrading precision-guided munitions. It is successfully targeting military assets. It is disrupting reliable communications and radars. We're seeing the proliferation and growth of what I would refer to as low-cost, mass-produced EW equipment in Gaza, things like GPS jamming systems. In fact, I would argue that the successful incursion by the Ukrainians into the Kursk Oblast region in August of 2024 is primarily due to two factors: drones and electromagnetic warfare.
Mm-hmm. What can we take away from that as far as what tactically the Army as a whole and you and your team in particular need to do, Travis?
So when we look at Ukraine, we see a lot of speed in the EMS. A lot of change happens rapidly. So one of the primary factors that we have to do is reprogram our systems across the entire Army and hopefully have some interoperability across DoD systems. When you see change like within weeks, not months or years, it takes a big shift in the way that we look at the environment.
I think that of all the things that you said there, as an outsider looking in, thinking about this from a joint perspective may be one of the most challenging things, because I imagine the other services have their units like yours that are looking at this. What's that cross-service collaboration look like in your view?
So if we look at what's happened in the past, we talk about data centricity a lot. Really, that's a key factor in success in the EMS. We have a lot of data that's raw, a lot that's refined. What we really need to do is share that data at the right time and place and have refined data that gets after targeting and things that are important, so we don't have cognitive overload on decision makers and targeting processes. Really, it comes down to lethality of our systems.
Dave, the data issue is one that everybody is wrestling with, working through, trying to figure out. What are the most important pieces of that in the work that you're trying to do? Is it just how the data moves through the system, who has access to it, security of it, all of that? Something else that I missed?
Well, it's all of those and above. So as Travis said, we have to be able to rapidly reprogram our systems. And what we mean by that is really updating our software, our data, and our algorithms that govern how our systems operate in the EMS. And that can be anything from tweaking sensors so they properly analyze and characterize a signal of interest, to fine-tuning our electromagnetic countermeasures so they're more effective against the adversary. And it all starts with the data. So we have adopted what we refer to as a platform agnostic approach. We want to create software that operates across disparate platforms. It's very different from how the Navy and the Air Force approach today. And that has to start with understanding the common data standards for both sensing and effecting.
Mm-hmm. Are those standards established, or are those standards that you're in the process of developing? What's that trajectory look like?
Well, that's interesting. So we are in the process of participating in what we call the RF, or Radio Frequency Data Pilot. It's an R-Cyber-led effort. And one of the main objectives is to identify the common standards associated with sensors and effectors. And we have identified, there are quite a few out there, the different standards. What we really need to do next is to make recommendations as what the Army MIL standards should be, so that industry partners can use those standards when they produce their new solutions for us.
You have both talked about the ability to get data where it needs to go, and you've both talked about modernization and so on. Are the techniques to do that in the EMS landscape similar to, different from other aspects of modernization that the Army's undertaking?
Yeah, so I'll take part of this. I think our Signal Corps really is the lead on sharing data. You know, they're the providers of comms and data links and things like that. So really, EMS data is no different than comms data or other information that has to flow across the battlefield. The real challenge here is the volume that we're going to see If we take raw IQ files from across the electromagnetic spectrum, that's literally like the ones and zeros coming off of the different signals that we're seeing. That's going to overload any network, knowing that we have finite bandwidths and limited time to do data transfers. That's why in the previous question I mentioned refined data. We have to have enough compute and storage on the front edge to narrow down to where it's perhaps just textual data that's going back and forth, and limiting those big files that we need to send periodically.
Travis mentioned edge computing, Dave. How does that evolution, that transformation really, not just in the Army, but all across the military, how does that inform the way that you're thinking about EMS and the way that you're going to do this work moving forward?
Yeah, the whole issue about data standards and edge computing, in my mind, segues directly into artificial intelligence and machine learning. So we believe that artificial intelligence is going to have a huge benefit to reprogramming in the future. It's going to do several things for us. First of all, it's going to reduce or accelerate our reprogramming cycles. So instead of something taking weeks, it might take just days or hours. It's also going to help us enhance our sensing capability. So it should do automatic characterization of a signal, auto identification. So that is a target tracking radar, or that is a frequency hopping radio. It will do anomaly detection. So as we are going through the EMS and we find a signal that doesn't look just right, it's going to raise a red flag and say, hey, this signal parameter is off. Either our sensor is not working properly, or perhaps the adversary has adapted and we have to change. And then it should also be able to offer reprogramming options for us. So based off of a modification that the adversary has made, we need to make a tweak here, and that will be automatic. Now, there are some challenges with AI. So first of all, you need a very large amount of quality data to train these models. Secondly, there's just an issue of trust. So AI has a propensity to hallucinate, and it's going to take some sets and reps before our soldiers and our commanders trust these systems. And then lastly, just I would say talent acquisition. So we have to be able to retain and attract quality folks that can both reprogram systems and work with AI. And those are high demand, low density folks.
Yeah, and the training idea that you talked about, I was thinking about that the moment that you mentioned artificial intelligence. What would you consider the state of your data now as far as being of sufficient quality to be able to use it to train AI?
Well, the Army took a break during counterinsurgency operations, and we did not heavily invest in EW now. So we need to get more equipment out to the field globally so that we can pull in this IQ data to build out that repository in order to train our systems.
Travis, quick final thought. Oh,
yeah,
go ahead,
I'd
please.
like to jump in there too. So I think, when we talk about training, a lot of times on AI, we talk about modeling of systems or signals and those type of things. There really has to be a balance between what the AI is doing and what the operator is doing. We want to have a trust but verify type architecture in place where my EW operator has a system that's answering questions for them, but they're trained and educated on why is it coming up with that particular answer, and then have the ability to fill in the gap when that automation should happen to fail.
I think it's important to note that AI is not meant to replace our operators or our capability developers, rather to augment their skills, allow them to move more effectively and efficiency in the EMS, and really focus their energies on higher level tasks.
Dave, Travis, it's great to have you both here. Thanks for joining me today.
Thank you.
Thank you.